Lesson 2.5, Inequalities. An equation is an equality. It's a statement that two values are equal to one another. It contains an equal sign, whereas an inequality is a statement that two values are unequal. It provides an indicator as to which value is higher, and it will contain one of the following. This symbol means is less than or is fewer than. This symbol means is greater than or is more than. This symbol means is less than or equal to or at most. And this symbol, which means is greater than or equal to or at least. Solving an inequality follows the same steps as an equation, but there's a major difference which we will go over momentarily. The first step is to distribute. The second step is to collect like terms on each side. The third step is to add or subtract. And then the fourth step is to multiply or divide. And here is that major difference. If multiplying or dividing by a negative, we have to flip the inequality symbol. So to solve single-step inequalities, we have a few examples. I have 3x is greater than 18. I divide both sides by 3, and I get x is greater than 6. Here I have x divided by 5 is greater than or equal to negative 13. I multiply both sides by 5. Now, even though this is a negative, I'm multiplying by a positive, so I don't flip the inequality. So I have x is greater than or equal to negative 60. Here I have x minus 6 is less than or equal to 21. I'll add 6 to both sides, and I get x is less than or equal to 27. And here I have negative 6x is greater than 36. I'm going to divide both sides by negative 6. I'm dividing by a negative, so I have to flip my inequality. X is now going to be less than negative 6. So anytime you multiply or divide by negative, you have to change that direction. To solve two-step inequalities, here I have a few examples. I have negative 3x minus 5 is less than 10, so I'm going to add 5 to both sides. Negative 3x is less than 15. I am dividing by a negative. So we'll put like a little arrow there to indicate, hey, this is important. Dividing by a negative means that I flip my inequality. Here I have x divided by 3 minus 3, so I add 3 to both sides. X divided by 3 is less than or equal to negative 3. Multiply both sides by 3, and I get x is less than or equal to negative 9. Here I have negative x plus 2 is greater than 7. I'm going to subtract 2 from both sides. Negative x is greater than 5. And when I had an equal sign, if it was negative x equals 5, I told you to switch the both signs like that. Well, we're going to do the same thing, but because that x is negative, we have to flip that inequality. Essentially, we divide by negative 1. Here I have 4 plus x divided by 6, so I'll subtract 4 from both sides, and I have x divided by 6 is greater than or equal to negative 9. Multiply both sides by 6. I am multiplying by a positive, so my inequality does not flip. Okay, when we have multi-step inequalities, whoops, sorry about that. We follow the same pattern as we did when we had multi-step equations. I have some distribution here. I need to multiply in this negative 6, so I have negative 3 minus 24x minus 36 is greater than negative 11. Negative 3 and negative 36 give me a negative 39. I add 39 to both sides. A negative 24x is greater than 28. Divide both sides by negative 24. I'm dividing by that negative. So that tells me that x is going to be less than, okay, 28 and 24 don't divide evenly, but I can reduce. 28 and 24 will both divide by 4, giving me 7 over 6. So I divided both by 4. Here I have 30 minus 6a is less than negative 3 times 5 plus 7a. So I need to multiply that negative 3 in. I have 30 minus 6a is less than negative 15 minus 21a. I'm going to add 21a to both sides. So I have 30 plus 15a is less than negative 15. I'll subtract 30 from both sides. Give me 15a is less than negative 45. I'll divide both sides by 15, and I will have that a is less than negative 3. Okay, so that's how we'll solve the inequalities. But sometimes we have to graph them. We graph them on a number line. These are single variable inequalities. So here's our number line. We use circles and shading to indicate all of the values that make the inequality true. So an open circle is used with less than or greater than. And a closed circle is used with less than or equal to and greater than or equal to. The reason being is this says it does not include the number. This one says it does include the circled number. Okay, here's how we graph the inequality. First we solve it. Okay, so we'll go ahead and solve this. I add 5 to both sides. I have negative 3x is less than 15. I'm going to divide by negative 3. Oh, I'm dividing by negative. Really important. That means I flip my inequality. So I've solved it. X is greater than negative 5. Then I create a number. Okay, create a number line. I'll draw my number line. Now you can make these as detailed or as undetailed as you'd like. I usually make mine pretty simple. I put an open or closed circle on the solution number. This tells me open circle. So my solution number is negative 5, so I go negative 1, 2, 3, 4, 5. Put an open circle on there. And then let me get rid of my over. That's better. Then I shade the number line on the correct side of that circle. Okay, x is greater than negative 5. So this is all numbers bigger than negative 5. Greater than. All the numbers bigger than negative 5 are over here on the right-hand side. So I shade this side. And now you can get as fancy as you want on your shading as well. I usually keep mine pretty simple. But if you want to make it a pretty shade, you can, or you can use a highlighter, a colored marker, or whatever you want. And that is how we graph that inequality. Okay, so let's do a couple more where we're going to solve them and then graph them. I have negative 2 is greater than or equal to 4 plus 6 plus 4. So that's 4p plus 10. I'm going to subtract 10 from both sides. I'll have negative 12 is greater than or equal to 4p. Divide both sides by 4, and I get negative 3 is greater than or equal to p. Now the reason I like this problem is because you may have been told in the past to shade the direction that the arrow points. That only works if your variable is on the left. In this case, our variable is on the right. So what we have to do is be very careful in which direction we shade. I have a less or greater than or equal to, so that gives me a closed circle on -3. And I'm saying that P is smaller than -3. So if I shaded the direction of the arrow, I'd be shading over here all the numbers that are bigger than -3. But I want all the numbers that are smaller than -3. So you really need to think about which direction to shade. Here I have 33 plus 4x is less than or equal to. I'm going to distribute in that negative, -x minus 7. I'll add x to both sides. 33 plus 5x is less than or equal to -7. Subtract 33. 5x is less than or equal to -40. Divide by 5. And x is less than or equal to -8. Make my number line. Closed circle on -8, and x is smaller than -8, so I shade in this direction. Why don't you guys try these two? Just pause the video, and then when you're done, come back and see how you did. Okay, so this one was fairly straightforward. We got a nice even number, but here we get a fraction or a mixed number. How do we graph this? Well, that depends a lot on who you're graphing it for. If you're graphing it in my class, you don't even have to get this fancy. If you're graphing it in my class, let me know that 0 is here. Let me know that -47/20 is on this side of 0, and that p is less than that. However, if you have to be pretty accurate, it's -2 7/20, which is about 2.5. So I go -2 and a half-ish. Put the number there. Oops, it should be an open circle. Let me fix it. So that should be an open circle. And then less than. Now you did remember to put open circles for the less thans and the greater thans, I hope. Okay, and that's how you do inequalities.